Okay, so paper 2, vector. Now what we can see here is, let's see, answer all the questions, and then you can see the question here. The diagram shows a triangle PQR. So you see, PQR. It is given that QT equal to 3 over 4 QR. So you can see QT 3 over 4 QR. So I have a suggestion on how to use this equation. So you do it like this. If you are given with QT equal to 3 over 4 QR, you divide them so that you can see 3 over 4, and so that you know QT is 3 parts. So here to here, 3 parts. QR is 4 parts. Here to here, 4 parts. And because of that, you know here to here will be 1 part. So it's good to put it in that way. And now let's continue. PQ equal to 8P. So imagine PQ is going to the left. So going to the left, 8P. And PR equal to 12Q. 12Q, PR equal to 12Q. PR is going up. Okay, so 12Q. Okay, now let's continue. A, express in terms of P and or Q, QR. QR. So let's see the diagram. QR is here to here. So this is easy. So you just do Q to P, P to R, and then you take this vector in the opposite direction and take this vector. Okay, so we write down the working in this way. A, number 1, QR equal to QP plus PR. So the QP is in the opposite directions of the 8P. You see 8P is to the left, but QP is to the right. So because of that, we have to take negative 8P. And the PR, the direction match with the information given. So PR is going up, and the information given is also going up. So it's 12Q. 12Q. Okay, so we get QR equal to that. And after that, we look at part 2. PT. Okay, PT, So let's look at the diagram again. PT is P to T. P to T. So we have QR. QR is going up. Because of that, it is good to do PQ plus QT. Plus QT, which is going up also, so that we can use this straight away. Okay, so I'm going to use, I write down first, PQ plus QT. So PQ is 8P. QT is where we use this information, 3 over 4 QR. So 3 over 4 QR. Okay, and 8P, 3 over 4. So QR is where we substitute what we found from the previous part, minus 8P plus 12Q. Okay, so we get PT. We simplified it. So we just need to multiply. 3 over 4 multiplied with negative 8. So we get negative 6. So 8P minus 6P plus 3 over 4 times 12. So we get 9Q. So end up with 2P plus 9Q. So this is PT. So this is PT. So we get PT ready. And now let's look at part B. Given PS equal to HPT, Rs equal to K 2P minus 7Q, where H and K are constants. Find the values of H and K. Okay, so to do question like this, first of all, we need to use the information given in this way. They give us PS equal to HPT, right? So we have to substitute the right hand side, the PT, with what we found in part 2 just now. So the PT is 2P plus 9Q, 2HP plus 9HQ. So this is PS. Okay. So the second information given is RS. So RS is K 2P minus 7Q. So we expand it, 2KP minus 7KQ. So that is RS. Okay, now in order to find H and K, we need to know how to relate PS and RS. So to relate this PS and RS, we look at the picture. So you see PS is P to this point, S. RS is R coming down to this point. So it seems like we can relate PS and RS by considering this triangle at this part, the PRS triangle. Okay, so where I just form an equation based on this, I can just put like PS equal to PR plus RS. So I can form the equation in this way. So where the PR, right, is 12Q, you can see the picture at the same time. The RS is 2KP minus 7KQ. The left hand side PS, right, is 2HP plus 9HQ. So you form an equation to relate the two vectors, and now you substitute with whatever you know, and we need to compare between left hand side and right hand side. So before you compare, right, it is good to gather up the 12Q and the minus 7KQ. Gather up what? Gather up the coefficient actually. For the vector P, 2KP, I just write it back. But for the vector Q, I write 12 minus 7KQ. So I do something like this. Okay. Now we can compare. So we compare like this. 2H equal to 2K. This compare with this. The coefficients of vector Q. Now the coefficients of vector, just now it's vector P. Now we compare the coefficients of vector Q, the one that I circle in green. You can compare also, and we should expect some simultaneous equation after that. So write down first. 2H equal to 2K. So H equal to K. So by comparing the green color circle, I have 9H equal to 12 minus 7K. So from equation 1, I know that H is equal to K. So let us find H first. 9H equal to 12 minus 7. The K I substitute with H because they are equal. K and H are equal from equation 1, we know that. Then 16H equal to 12. H equal to 12 over 16. Then you get 3 over 4. So we get the H. And then since H and K are the same value, so we should expect the K should be 3 over 4 as well. So we get the values of H and K. Okay. Now we look at part C. Given PU equal to MP plus 3Q. Okay, let's take a look at the diagram. PU, which is here, all the way up to this U. PU equal to MP plus 3Q. Where M is a constant, find the values of M. So find the values of M. Okay, so what we can see easily here is we know that PU and what we found here PT, they are on the same straight line. We call them collinear. Collinear. So let's say I do it here so that I can look at the picture at the same time. I do part C here. If PTU are collinear. Collinear means these 3 points are on the same straight line. Then we can use this formula. We can use PU equal to a constant. Let's say lambda PT. So we can set up a constant and interrelate two vectors that involve PTU. So I choose PU and PT. PU is given, PT is found previously, so that's why I choose these two vectors. Now PU is given in this particular form, MP plus 3Q. Okay, so MP plus 3Q. Substitute to the left. On the right, we have PT. PT is found from part 2. So let's look at part 2 again. So you can see that it is 2P plus 9Q. So that is what we found from A part 2, which is here. So we substitute this to the right hand side. Okay, now we just need to compare. So I expand right hand side first. 2 lambda P, 9 lambda Q, MP, 3Q. Okay. So after that, I can do something like just now, which is comparing the coefficient. M equal to 2 lambda. So these are the coefficients of vector Q. Then I can compare 3 with 9 lambda. Okay. So of course I'm going to compare the green color one first because I can find lambda, one unknown. If you compare the blue one, you cannot get anything because there are two unknown there. So 3 equal to 9 lambda, lambda equal to 3 over 9, lambda equal to 1 over 3. Okay, now I compare M equal to 2 lambda, lambda is 1 over 3, so I get 2 over 3. Okay, so I get lambda and M now. Lambda is not what they asked. Lambda is just helping us to find M. So we get M equal to 2 over 3 and we have done the questions. So from here you will realize this paper 2 question is 10 marks question. So we have to say that they are interrelated. Imagine if you are wrong at PT, then you use it in part C, then mistake already. Okay? If you are wrong in PT, you use it in part B, then the mistake will continue. So that's why it is interrelated. So must be very careful at the beginning, so that the information that you are going to use in future will make everything correct. Okay. Now let's see another situation. Okay. So let's go through another paper 2 question to build up more exam skill on vectors. Okay, let's see this. In the diagram, QP equal to 12A. So QP QP equal to 12A. QR equal to 10B. Okay, let me put the information. QP is to the left, and this is 12A. Okay, QR is all the way up, and it is 10B. Given M is the midpoint of QR. So as you can see here, M is the midpoint of QR, so which is here. So if it's midpoint, then let me put the information first. So all the way up to half of this will be 5B, and all the way up to here is another 5B. Okay. Now we continue with the information. Qn and P equal to 3, 1. Qn and P 3, 1. They give us the ratio. So the ratio given is 3, 1. So altogether there are 4 parts, and you divide the 12A by 4. Divide the 12A here by 4 because of 4 parts. Then you get 3A. 12A divided by 4 is 3A. So that means 1 part is 3A. 3 parts is 9A. So let me build up this first. I put in the diagram. So here to here, 3A. And here to here, oops. Okay, so here to here, 9A. Okay, now let's continue. Okay, given PS equal to HPM. PS, HPM. Okay, it's on this line, collinear. Collinear, P, S, and M are collinear. They can form equation like this. This one is what we discussed. And S equal to K and R. So it's a collinear concept also. And S, R are on the same straight line, so they can form an equation in that way. Where H and K are constant, express QS in terms of HAB. If they say HAB, that means you have to use this. You have to use this to help. Okay, so let's see. QS is Q to S. So PS is here to here. So we need to relate QS and PS. Okay, so we can relate it in this way. I know that QS is QP, you look at the picture at the same time, QP plus PS. So that means you want to go from Q to S, you can move a big round, Q to P first, and P to S. So why we move a big round like this? Because we know the vector of QP, which is 12A. We know the vector of PS, which is given here. PS is given as HPM. 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 Okay. So now we just need to work out PM. We need to work out PM. Okay. PM, we need to work it out in terms of vector A and vector B. PM is all the way from here to here. Okay. So I can move a big round. P to Q, Q to M. So I write down how I move first. I'm going to do P to Q, Q to M. And when you look at the pictures at the same time, so you will realize PQ is negative because opposite direction. Negative 12A. 12A is to the left, PQ is to the right. So negative 12A. Negative 12A plus QM. So QM is 5b. So we have set out the thing here, 5b. So it's 5b. Okay, now 12a minus 12ha plus 5hb. Okay, so it is good to gather up the coefficient in this way, so that later when you do comparison you can do it easily. So we get QS in this form in terms of H, in terms of H, A and B. Okay, so this one we settle. Now we look at part 2. QS in terms of K, A, B. So when you see K, right, so that means you have to use the NS equal to K and R to get the answer. Okay, so let's see QS is Q to S, but NS is here to here. So this, for this round we have to form an equation by using NS. So QS equal to QN plus NS. So QN 9A. NS is given K and R is given. NS is given here, K and R. So we substitute. Now we have NR to consider here. So we look at the picture first. NR is N all the way up to R. So you have to move a big round. N to Q, Q to R. So we have information in that direction. So that's why we have to use that way. N to Q plus Q to R. So 9A plus K. N to Q is negative 9A. Q to R is 10B. Okay, now I expand first. 9A minus 9KA plus 10KB. Okay, then I factorize the vector A, and I put the vector A at the back, and then 10KB. Okay, so I get QS. Okay, QS equal to this. Okay, so once you get QS, now we settle part 1 already. I mean we settle A already. Okay, we look at B. Hence find the values of H and K. So again, you can see both of these are QS. You can equate them and compare the coefficient. So that means let's say I call this number 1, I call this number 2. I can use 1 equal to 2. Then I have 12 minus 12HA plus 5HB equal to 9 minus 9KA plus 10KB. Okay, then I can equate the coefficient of vector A, or compare the coefficient, and I can also equate the coefficient of vector B, so which is this equal to this. Okay, then you will realize, this question is very similar to the question just now. So this is what they prefer to ask in paper 2. So I compare the blue one, I get this equation, then I simplified it. 3 minus 2h equal to negative 9k. 9k equal to 2h minus 3. Okay, so then just leave it as equation 3. Now I compare the green color circle, so I get 5h equal to 10k, h equal to 2k. I call it equation 4. So I substitute 4 into 3, so I get 9k equal to 2k minus 3. 9k equal to 4k minus 3, and then 5k equal to -3, k equal to -3 over 5. So you get the values of k, and we just use equation 4 to get the values of h. 2 times k, so h equal to -6 over 5. Okay, so we get the values of h and k. So let's continue with part C. Part C, given magnitudes of A equal to 1 unit, magnitude of B equal to 2 units. Okay, let's see how we use it. You look at the pictures here. If magnitude of A is 1 unit, then your QP, right, is going to be 12 times 1 unit equal to 12 units. So QP is 12 units. I can just write down first. I'm not sure whether we need to use or not, but I just write down first. If modulus A is 1 unit, then modulus QP is 12 units. 12 units. Okay, now let's see another information. Modulus vector B equal to 2 units. 2 units, you look at the picture. You see vector B is here. So 10B is going to be 10 times 2. 10 times 2 is 20 units. So that means if this is the case, then we manage to determine that QR equal to the magnitude of QR. Magnitude means that the length of the line is 10B, right? So 10 times 2, which is 20 units. Okay, so we are also given that QP is perpendicular to QR. So QP, QR, they are perpendicular. Okay, so find the magnitude of PS. Find the magnitude of PS. Okay, so I'm going to use, because of the let's see, 2-mark question. Okay, so I'm going to use this triangle, because this triangle involves PS. So they tell us that this is perpendicular. So we can use Pythagoras theorem to find out PM. So let's do that first. PM. Okay, so we do it. We do it at the side here. Part C. Okay, let's look at the triangle again. The right angle triangle of PQM. So just now we already discussed our PQ or our QP. Our QP is 12 units. So if it's the other way around, it's just the same. It's still 12 units. Okay. After all, magnitude is just the length of the line. So no matter what direction, it's just the same. No need to change it to -12 because it is magnitude. Magnitude no plus minus one. So always positive. So that means here is PQ. The magnitude of PQ is also 12 units. Okay, so this is 12. Just now we discussed here QR is 20 units. QR is 20 units. Now QM is half of it, 10 units. Okay, so QM is 10 units. So here 10. So we can use Pythagoras theorem to find PM. PM. If you don't want to write vector PM with modulus, then you just write PM. If you write PM without arrow, without modulus, that means it is the length. So it's the length. So you can follow the blue one, or you can just follow the vector PM with modulus. It's up to you. Then we use Pythagoras theorem, 12 square plus 10 square and square root. Then we press calculator, 12 square, 10 plus 10 square, square root. So we get 261.
Teacher,
Yes.
I thought QM is 5 units.
You see, it's 5b, right? It's 5b, then 5
okay.
times 2. 5 times 2 is 10. So that's why. Okay, so we get 12 and 2, 10. We use Pythagoras theorem and get this. Okay, now once you get PM equal to this length, now how to find PS then? PS. So what we can do is we make use of the information that we found, which is, okay, you see here, PS equal to HPM, and we know PS equal to HPM. Okay, so PS equal to HPM, and we know H is a negative value. Seems to be not reasonable, because you see from what we know, right, PS and PM is in the same direction, so should be positive, right? The H should be positive. Let me double check first. Okay, let me double check with this vector. The last question, question 2. Question 2 should be 1/5 and 2/5. Okay, so maybe we have a mistake somewhere here. Okay, let me double check with this. A part 1, 12 minus 12 HA plus 5 HB, this is correct. A part 2, 9 minus 9K plus 10KB. A part 2 is correct. Part B, H equal to 2K is one of the equation. Another equation is, something wrong with this equation. Okay, 12 minus 12H. Oh, there is a mistake here. I do correction with black color. 12 minus 12H equal to 9 minus 9K. Then rearrange, 3 minus 12H equal to negative 9K. And then 9K equal to, bring to the right, 12H minus 3. There's a mistake there. Should be 12. So I correct it in black color. Then substitute 4 into 3. So this is 12 again. 12, 2K should be 24K. 24K minus 9, 15. 15 equal to positive 3. K equal to 3/15. 3/15. So should end up with 3/15 is 1/5. So it's a mistake just now. Okay. Now I use K equal to 1/5 to find the H. The H should be, okay, 1/5. So I substitute 1/5 here times 2, then it is 2/5. So 2/5. 2/5. Okay, I get H, 2/5. This is the correct one. And let's come back to here. Okay, PS equal to HPM. This is where we stopped just now. So the h is now correct already, 2/5 I put here. Okay, so I change both sides to modulus. Both sides to modulus, something like this. And then I'm going to find modulus PS by the way. So h is 2/5 and modulus PM is this value, 2 square root 61. 2 square root 61. So 2 square root 61 I substitute here. 2 square root 61. Okay, then just press calculator. 2 square root 61 times 2/5. Okay, so which is 4 square root 61/5, or put it in 6.25. 6.25 unit. So this is correct.